Alright, so notes today are over 2.6, which are arithmetic and geometric sequences. Alright, so we're looking for patterns. So the first one we're going to take a look at is what an arithmetic sequence is. It's a difference between consecutive terms is always going to be a constant. This difference is called a common difference. The common difference can be addition, where the terms are increasing, subtractions, where the terms are decreasing in value. Alright, so here is our formula. And I'm going to explain it as I start plugging it down with this right here. Alright, so for example right here, I can see that this one has a common difference of plus 2, plus 2, plus 2. Alright, so whenever I look at what my common difference on this one here is just plus 2, that's what they're looking at for the D. So for right now, we're just going to put D equals positive 2. For this one, I had to switch this because it was a negative, or it should have been a plus. Because each of these should be a minus 5, minus 5, minus 5. So make that a positive 4, and it's all minus 5s. So our difference is going to be negative 5 every time. Okay, so then we move it down here, and now we're going to make one of these out of that. Alright, we're going to try to make our little sequence predictor out of that. So if I look at this one right here, what's my common difference? I've got a plus 3 every time. So that tells me first off that it is a arithmetic sequence because it's same addition. Okay, so then I know right now, and I'm just going to list what I know so far. I know that D is equal to positive 3. Okay, let's explain all the rest of this. It says look for the nth term. The nth term is just, for now, we're just going to leave that A to the end because that's what's going to pop out. That's kind of what's going to pop out of this whole sequence function. My first term is just whatever the first number is. Like on this one is 1, this one is 0. On the original one it's positive 4, it's 2. So right now they just want to know what the first term is. We're going to call that A sub 1 is equal to 1 on this problem. And then the term position, and then we put D. Okay? So term position is like, this would be term position 1, term position 2, term position 3, term position 4. Alright, so we're going to write a rule. So this is where we come back up here. Here's our rule. Write a rule for the arithmetic sequence and check your answers. So we're going to start with A to the n, or A sub n, not to the n, A sub n is equal to whatever the first term is. On this one it's 1. And then we're going to go plus n minus 1, because I don't know n yet because I haven't plugged anything for that sub n, so I don't switch that yet, times D. So it's positive 3, so just put 3. Alright, so this is my function rule. Let's show you how you check this thing. Let's say, for instance, I want to know what the fourth term is going to be, even though I know what it is already. So let's say I put in a sub 4. So that means I'm going to go over here and put in 4 minus 1 times 3. Well, if I simplify that, I get 1 plus 4 minus 1 is 3. So now I got to multiply first. 3 times 3 is 9. 1 plus 9 gives me 10. So what this just said was the fourth term should be 10 if that's the right rule. So if I look at it, yes, the fourth term is 10. Right? So let's do the same thing with the second one. I have a common difference of minus 4, minus 4, minus 4. Alright? My D value is then negative 4. My A first term is 0 on this one right there. Okay? So, now I just go start plugging everything in. A sub n equals 0 plus n minus 1 times 3. My bad, I'm going too fast. Times negative 4. So that's a negative 4. So that came from that d right there. Up in the formula, I put a d in. Alright, so let's make sure that our little formula works. I'm going to shorten it so I really don't need a 0 in front. N minus 1 times negative 4. So there is my rule. So let's try one. I'm not going to try. So the first one was 0, the second one was negative 4, third negative 8, fourth negative 12. I want to see what the fifth is supposed to be. Because you can kind of tell by, hopefully you can tell by looking at it, but I just want to make sure that I get the same thing if I do this. So I get 5 minus 1 times negative 4. So 5 minus 1 gives me positive 4. 4 times negative 4 gives me negative 16. So if I do follow this rule one more time, negative 12 minus 4 does give me the negative 16. So yes, fifth term is negative 16. Next question, could you write this function in the form f of x equals mx plus b? The answer to that question would be yes, because this is really just linear. Because this is really your slope, and this is your y-intercept. So the answer to this is yes. Could you write this in the form of f of x equals mx plus b? Again, the answer is yes. All right, because here's how I would do it actually. F of x equals slope of 3. N minus 1 is like x. I guess this would be f of n. And then the y-intercept is plus 1. So it's the same idea over here. F of n equals slope. Slope was negative 4, that's the common difference. X value instead is n minus 1, so we just replace that with n minus 1. And then this time the y-intercept was 0, so I don't really need it. So there we go. So I got a slope, I got a y-intercept. I got a slope, my y-intercept 0. Okay, let's turn the page. Let's talk about geometric sequences. So on this side, common differences were always addition and subtraction. Boom, boom, addition, subtraction. On this side, a geometric sequence ratio between two consecutive terms is a multiplicative. This ratio is called the common ratio instead of common difference. So instead of common difference, we're going to use common ratio, R. Unlike in arithmetic sequences, the difference between consecutive terms varies. So in other words, this isn't going to be 3 plus 9 every time. It gives me 12, because 12 plus 9 doesn't give me 48. Instead, it gives me 3 times 4 gives me 12. 12 times 4 gives me 48. 48 times 4 gives me 192. So my common ratio is times 4. So R equals 4. Okay? What is the first term of this sequence? It's pretty easy. Just go point right there. The first number is 3. All right? So this time, my common is times 80 times 1/4. 20 times 1/4 gives me 5. 5 times 1/4 gives me 5/4. So I put a 1/4 there. The first term this time is 80. What am I dividing this time? Or I'm going to use multiply by fractions. I'm timesing by negative 1/2. Timesing by negative 1/2. All the way through. So there's my common ratio, negative 1/2. A, the lead one, is 120. So there you go. So now if I'm going to plug this in, it's going to go 120 there, negative 1/2 there. Okay, so that's what we're going to do on the bottom. We're going to go one more step further. So let's figure our pattern first. Our common ratio is times 3. R is 3. Our first number is 1, our first term. So our thing should look like this. A to the n equals first term, so it was 1, times whatever R was 3, n minus 1. Alright, they want me to check it. So far I have 1, 2, 3, 4. I'm going to go for a fifth. So if I try a to the fifth, I get 1 times 3, and then 5 minus 1 is my exponent. So I do exponents first. So I got to go do 5 minus 1 first. 1 times 3 to the 4th power. 3 to the 4th power. So I got 3 times 3 is 9, 9 times 3 is 27. 27 times 3 is 81. So I got 1 times 81. So my fifth term, if I times by 3, should be 81, which is. So there's my check. So there is my rule. There is my check. All right? Try this one. Times negative 3, times by negative 3, times by negative 3. There's my ratio. I start with the number 2, plug in. So far, piece of cake, right? All I got to do is plug in a 2 for A times negative 3 for R. N minus 1. There's my rule. There is my rule for the geometric sequence. Alright, test one. So I want to see what the 1, 2, 3, 4, fifth term is going to be again. 5 equals 2 times negative 3, 5 minus 1. 2 times negative 3 to the 4th power. 3 to the 4th, we just figured over here, was 81. So now that I've done the exponent, I take it times 2. This is negative 162, which, check the math, but negative 54 times negative 3 should give me, that's positive, I forgot, that's supposed to be parentheses. So fix that for me. Positive 162. Now, don't forget by a rule, I should have done this on this part. It's actually here too, but it doesn't matter because it's not negative. Okay? So, times, last one, times by negative 1/2, times by negative 1/2, that's not times a negative 1/2, that's times a negative 1/5. I'm assuming that means that could be a 1/2. I'm going to switch it so it fits what I'm trying to do. Because otherwise this would have been not non-geometric, wouldn't have been geometric or arithmetic. It's going to be neither. So I couldn't have done this, so I'm going to switch it. Switch that to a 1/2. Our pattern stays negative 1/2. So there is my R value. A first number is negative 10. I plug them in. A to the n equals first number times r. On this one here, r was negative 1/2. This time I'm going to remember to put in parentheses. N minus 1. Okay. Let's see what the next one should be. To me, it looks like it's going to be negative 1/4, because 1/2 times negative 1/2 is negative 1/4. Let's see if I get that if I do the fifth term. 5 goes here, negative 10. We got to do the exponent first again. So then 5 minus 1 up here. Negative 10 times negative 1/2 to the 4th power. Negative times a negative times a negative, 4 times gives me a positive. 1/2 to the 4th power would be 1/16. Yes. So negative 10 times 1/16, that's negative 10/16. Which reduces to negative